Hi guys, welcome to Learning Electronics Repair. I have a package here. This is from Fnirsi. Okay, so this is the LCR-P1 multi-parameter precise measurement infrared decoding function automatic device recognition. And this is a transistor tester, so it says, yeah, transistor tester. It's interesting that this comes up right at this moment in time because I've been playing around with things like op-amp testers and such like, capacitor discharger, those sort of bits of interesting equipment. So let's have a look at this. The reason I was interested in this, I will say right now, is because this is for testing through-hole and surface mount transistors and maybe other devices as well. So let's have a look in the box and see what we have. I will just mention that Fnirsi sent me this free of charge. I've not paid for this. It is a review sample, but I'm not being paid to make this review. So although this is a free sample, I have full freedom to give an honest and true opinion of this. Okay, so this is it. So here we have the tester, a little box with accessories in. Okay, USB. This is the little adapter look for testing surface mount devices. Yeah, diodes, resistor, capacitor, yeah, transistor. 3 little cables for clipping onto devices, or you can put them in here. And we have the instruction manual. Rechargeable battery, USB type C. Okay. Let me see if there's anything in English. Yes, we also have English. So what can we see? Oh, there's a high voltage button for Zeners. There's an infrared receiver. This is for testing infrared remote controls. We can have a little play with that. Mode selection, transistor or IR decoding. So you have to switch to that. 1, 2, 3 transistor testing, KAA voltage regulator, diode testing. Okay, and this will display gain, base emitter voltage, voltage base emitter, yeah, all the usual sort of parameters we have for transistors. It will test the gain from 10 to 600 basically. Okay, diodes, forward voltage drop up to 4.5, so that's great for LEDs. Voltage regulators, this is Zener Diodes up to 32 volts. FETs, JFETs, IGBT. Mosfet, okay, interesting. Oh, it's not quite spelt that way, Mosfet or something, yeah. I'm not even sure what one of those is. Okay, I always find something new, I guess. This is for thyristors, capacitor, resistor, inductor, and the NEC protocol infrared code. Here is the LCR-P1 on AliExpress, $31.89 on special offer at the moment. So this is not a particularly expensive device. If I have any additional discount codes or offers or links, I'll put them in the video description. We know these things are very simple to use, so let's give this a try. Let's try a few through-hole components first. I want to try a few inductors as well. Zeners up to 32 volts, and then let's try some SMD devices and see how well it actually works. Okay, the obligatory screen protector, we'll remove that. Let's see if this has any charge in it. It does. So we'll have a look at a few through-hole devices first, but I think probably what you guys are really interested in and what I'm really interested in is how well the SMD adapter works with this. So we can just attach some of these leads. Okay, this is a double resistor, so these are 0.22 ohms, okay, from either end to center, or it's 0.44 across the whole device. So let's see. This should read 0.44. Test. Unknown. Test. resistor. But it says the value is 0. I find that with a lot of these testers that very low value resistors don't work. That's not unusual. Let's just try something a little bit higher. Here's a big one, 2 ohm. Okay. Yeah, it says 2.4. Okay. I'm not sure how accurate these things actually are, to be honest. Another large one, 4 ohms. Yeah, 4.3. I'll try something high value as well. So these are 4.7 mega ohms. I've noticed these clips don't really work with very small leads like this. Okay, they're too thin. Can you see that? So let's put the resistor into the tester itself. Try that. Yeah, 4.7 meg. So that's, yeah, definitely working. Let's test the Zener diode. So according to the manual, we put this between K and A. And here, okay, we press the Zener button and then we hit test. This is a 27 volt Zener and we have 26.85, so that works fine. Okay. It does mention there's a prompt if you put them in the wrong way round, so let's have a look at that. Okay, so let's see. Zener test with it in the wrong way round. Yeah, it's telling us it's reversed. Okay, that's fine. Okay, onto capacitors. So this is a 10 nanofarad. Between any two pins again. Test. It takes some time, it gets it right, okay. It does mention, by the way, that if you plug a charge capacitor in, you may get some sparks when you put it in. That's because it's discharging the capacitor. So this does have a facility to discharge capacitors if you plug a charged one in. It doesn't mention the highest voltage that will handle. It does recommend that you discharge the capacitors before insertion anyway. But I did mention that it does actually have the ability to discharge capacitors. Let's try something a lot larger. So this is a 3300 microfarad. Let's connect this across here because the legs are quite long. We need a bit of space. So we connected from 1 to 2 right across. Okay. Test. Unknown or damage. Go again. Yeah, it's got it. And the right value. And the ESR it's telling as well. Okay. Now for inductors. It says the smallest inductor it can read is 10 microhenry. So we'll try that. Here we have some. Will the clips go onto these? Yeah, these clips are still not really good. Okay. Test. In progress. Sorry, in process. And it read it, so it says 12 microhenry, so it does operate at the levels it says it will. Let's try something a bit bigger, okay? Something a bit bigger. Again. Yeah. That's a bit unfortunate, really. I have some here, you can see. Okay, these can't cost any more than those other ones do. And these clip on properly. So, it's not a big issue, guys, if you buy one of these. Yeah. Just as long as you've got some other clips, I mean. But it's a bit silly. I would say. I don't see why we get clips that really don't work well, and we can see that we've tried a number of times. Okay, so components, testing process, yeah, 606 microhenries. Here's an even bigger one, probably off a crossover, this audio speaker crossover. So this has very thin leads, but these should be just fine. Okay, let's try it. Okay, 271 microhenries. I'm going to test SCRs as well. I have through-hole ones. I'm really not sure if I have any SMD ones, so we'll test these. And then let's go to SMD testing. So here we are, PCR406. Okay. So one press turns it on and another press actually goes into test. Yeah, that's actually a transistor. Interesting. I've got those down as being SCRs. Let's just try that on my peak analyzer. Sensitive or low power thyristor. Go back onto the other one again. Okay. Transistor NPN. That's very interesting. I'm going to look up the data sheet of this. Let's just settle this because the two tests are telling me different things. Okay, so PCR406. Well, that certainly is an SCR, so it misidentified that one. I'll mention to Fnirsi, in fact they'll watch this video, maybe a firmware update to fix that. You can see the device there, so it is the one I said it was. I don't have any more SCRs. I have some Triacs. It doesn't mention that this will test Triacs. I don't know if the other analyzer I have will either, but let's just try out of interest. So here we have BT139 600E. As I mentioned, this is not documented to test these, so let's just see what happens. Okay, I'll hold this down because it's very tight in there actually. With the large leads, test in process. And it says it's a PNP transistor. Okay. Again, I don't actually know if this tests these, but do bear in mind, guys, it doesn't say in the user manual that it will test Triac, so this isn't documented anyway. Yeah, that did though. In fact, in the manual, it does say unidirectional SCR and bidirectional SCR. That would be a Triac, so it does state it will test them. That was a valid test. So SCRs and Triacs, this has issues, and I will pass that information on to Fnirsi. Here's the little adapter for the SMDs. Okay. We unplug this. Yeah, that's fair enough. It has a key, so it's located to go in one direction. Yeah. I'm not sure then what this is for because this doesn't plug into anything. Can you see that? And we plug the adapter in. Right, let's see again what this will do. It doesn't mention in the manual about this little SMD tester, so I think we can probably figure this out. This is clearly for Zeners. I'm pretty much expecting a diode we put across any two pads, and inductors, capacitors, yeah, maybe resistors as well. I do see one issue with this straight away. I've realised. Well, I think I see an issue. We're going to try it, but let's have a play with this and let's see what it does. Here are some SMD devices. These are 0805. They'll easily fit across there. What's the smallest that will? Well, I have some 0402 capacitors. Let's try one of those. Okay, here is a 0402. This is a very small component. It will fit across there though. Let's see if that will actually test off. I need to push down on it with something. So let's see if we get a connection. It doesn't see anything. Let's just put a bit of pressure on this. This is just plastic. Okay, let's see what that does. Yes. Okay. And it says 977 nanofarads, and this is a 1 microfarad. So it will test down to 0402. So a larger one shouldn't be a problem. This is a resistor 0805, 10 ohm. So this is 2 sizes up. We have 0603 in between. 10 ohm, let's have a look. Again, I'll probably need to push down on it. Yeah. Probably some plastic tweezers would be the thing to use here. I don't have any to hand. So we'll just go with my technique again. Okay. Yeah. SMD inductors shouldn't be a problem either with this. We just stick it on. Easy to push down on this one. Yeah. 10 microhenry, which is what it is. So this is actually a diode BAT54. Let's see what it thinks of it. So I'll push down on this, hit test. And we have a diode, okay. Forward voltage 320 millivolts. This is like a Schottky diode or something similar to that, okay. This is another small diode. So this is 1N5819 surface mount. This is known as a SOD. Yeah, SOD, small outline diode. Yeah, that's the package. Hit test. Go. Yeah, again. And it's reading it like a Schottky type diode, so that works fine. Let's try a transistor. So 1AM, MMBT3904, SOT23 transistor. Again, here it is. Very small. You have to make sure you get it the right way up and not upside down, of course. So you want some magnification to do this. This is a pull. You can see this is not a new one. So let's see if we can test this. Okay. I'll actually try to hold this down just using the end of the tweezers like so. We can see we have a good connection. Test. And then again. Yeah, it's got it. So that's good actually. It's saying the base is on pad 3, which is correct. So that's fine. But I think this is where another issue is going to crop up. So these are very common packages for diodes and such like. This actually, we'll have a look at this one. I'm not sure what this component is. Let's see if we can find out. These are all pulls. It's just a 2-pin device. Could be a diode, could be a capacitor even. Let's have a look, see if we can identify this. It's a capacitor, okay. 120 microfarads. So yeah, it says 150. Nice. Here is a, well, let's have a look. I mean, it could be anything from a Mosfet, a transistor, or a voltage regulator. And I don't think we're going to be able to test this. So we have a number on it, EH18A. Without looking up the data sheet, I'm not sure I can test them. So this sender tab will be connected to there, you would think. But the problem is, oh yeah, maybe I can if I just position it like so. Get the middle pin between the two. Okay. What is this thing? As I say, this could be a voltage regulator or something that isn't supported anyway. It's not sure what that is. Let me just go again. It just says it sees a resistance. So this is some sort of MOSFET. If we have a quick look underneath it, you'll see we have a large tab with like 4 pins going to the edge, and then we have a row of 4, okay? So the large tab would be the drain, and then one end or the other will be the gate, and the others will be the source. Let's have a look at the data sheet. And here it is. So yeah, we can see drain, the gate is on the right hand side, source. Okay, now I'm interested to see if I can get this to fit across these points to test. So it's basically the right way round. This would be the gate. I only need to get a connection onto one of the source pins. I don't need to get to all of them, to be honest. Move it that way so it's not going to short to the gate. So that should do in actual fact. Let's hold this down. I'll try and do it at an angle where I can make sure I actually have a connection here. Okay, that looks good. I won't alter the angle of this. Let's just try it. So, test. And it sees that as a diode. Yeah. Again. So these are new ones. I mean, you would think that would make a contact. I'm going to help it a bit by putting a bit of solder on, because most likely you want to test poles anyway. Okay, let's give that a go. Yeah, it's got it. So putting a bit of solder on did help. Right, interesting. Let's have a look at the infrared test. So just switch it on. The switch is on infrared decoding, IR decoding. So take out the remote. And nothing happens. Okay. Just point that at my mobile phone. Oh yeah, it's definitely working. You can see it, but it doesn't do anything. You have to hold this in for a certain amount of time, maybe. No, it doesn't do anything. Here's the remote for my overhead camera system. Try this one. Again, it works. Let's go again. Oh, you know what? In the meantime, now I press this one, it saw it. That wasn't even pointing at it. But it doesn't work for this one. So I'm not sure how useful that is. I mean, what would you think? Is this faulty? Is it not compatible? Well, you'd have to go back to the old method, point it at your mobile phone camera. I mean, yeah. That one straight away. 50-50, yeah. What did I like and what didn't I like? Well, the supplied clips are just not good. Maybe this one's even faulty actually. It just doesn't go down properly. Actually, this one seems better, so maybe that was just me being unlucky. Let's see. Works better now. Oh, okay. Quality control issue with the clips, yeah. Easily enough fixed. So that isn't a big issue as such. You'd expect a bit better, but yeah, not a big issue. Didn't work with SCRs and Triacs. I compared using my other tester, the Peak, and that worked just fine, okay. This SMD thing is a great idea, but you have to put quite a bit of pressure on. You'd expect that to some extent. What I don't like is the fact that there are some packages of SMDs that this won't test. You can't, you know, especially the ones with a tab and a center pin won't fit in there, such like. But having said that, it wouldn't be difficult to just figure out which pads go to where, okay, and make one. Make one if you really want to, because I think it's actually a good product. It just needs a bit of tweaking. So I'm wondering now actually to make another SMD thing here just for the transistors, so without these on, because it's fine for these 2-pin devices, just with some pads that will take easier, the type of Mosfets we find in VRMs, and there's probably 2 or 3 different types, and you could probably get them on there, yeah. So that's an interesting project. Yeah, improve it. What do you guys think? Yeah, would you like me to have a go at that? I'm quite keen, because testing those sort of Mosfets, especially off VRMs, is where I usually come across faulty Mosfets, and it would be nice to be able to just hold them against there. Yeah. Okay, so I won't give it an out of 10. It's a kind of like in between this one some ways. It does work rather nicely, but then there are just like little things about it that could be quite a bit better. Okay, so I hope you did enjoy that, and I look forward to seeing you all again soon on Learn Electronics Repair. Ciao for now, guys.